All right, so now that we've actually looked at energy wavelength for photons, let's talk about actual emissions, so light that we can actually see being emitted from any given type of atom. Okay, and so one of the interesting things about atoms is that if you hit them with the right frequency light, the right amount of energy for a light, sometimes they emit photons of a different color or energy light. And so it was known, it's been known since the early uh, 20th century that if you expose helium or neon to a good amount of energy, you'll actually get photons that will emit, or get light that will come off of that. And what it was found was that there are only certain photons, certain colors that would be emitted from a given atom. So for helium, the only visible colors of light were this kind of violet light and this purple light, this green light, this red light. For neon, there were more bands, some more colors of light that were emitted. But the point was that there wasn't any of the light in between these bands. So there was nothing in this blue region here, and there was nothing over here in the yellow, and until you get to this kind of orange band from this green. And so what that indicated was again that energy was quantized, as we discussed on the previous set. It's only allowed, but for particular atoms, only certain energy spacings are allowed for energy levels are allowed for the differences in energy for an electron. And you might be asking, what aren't we talking about photons here? No, well, actually, we're talking about both, because the reason why these photons are being emitted is due to excitation of electrons. And so basically the idea is a photon comes in here, hits an electron that's at a particular state, and these little rings here are representing energy states for an electron. Okay, so this innermost ring is where the electron is normally is, and sometimes you get a photon or some light to hit it, and it excites that electron up to a higher energy. And what happens then is it relaxes back down to its ground state, or where it normally is, because it wants to be at the lowest energy possible, just like, you know, a cat or me on the weekends, the lowest energy possible. So it relaxes back down, but when it relaxes back down, when it got excited up, it absorbed a photon. When it relaxes back down, it emits a photon. And so there are only certain spacings, so it always relaxes down to this energy level. It never relaxes down to halfway between this energy level and this energy level. It never relaxes down to this place right here. And this represents the allowed energy levels for hydrogen in this case. And this is the Rydberg equation. Notice that these levels n of I, n of f, so that's the initial level, that's the final level, and these are all quantized numbers. They're either 1, 2, 3, 4, 5, so they're all whole numbers, and they're quantized in that way. There's no level 1.5, it's either level 1, level 2, level 3, and so on and so forth. And so if you came across a problem like this, indicate which energy is emitted or absorbed when the following electronic transition occur, when it goes from n of 2, so a level 2, to a level 6. Well, if an electron is going from a level 2 to a level 6, it needs energy to increase its level. Okay, so it needs energy to increase its level, and so that means it's absorbing the photon if it goes from n of 2 to an n of 6. That would be like going from this space right here to a ring that's not quite drawn, but it's outside of these rings here. So it's increasing whenever it goes from inner to outer, or from lower level to an upper level. So if the electron falls from an orbit of a radius 4.7 angstroms to a radius of 0.529 angstroms. Angstroms is just a length unit, okay? So if it's here and then falls down to here. This is further away, which indicates it's a higher energy level. This is a lower energy, this is closer, so that's at a lower energy state. And so this would actually be emitting a photon because it's going from a higher energy state to a low energy state, and that energy is given off in the form of a photon. And then if an electron moved from an n of 6 to an n of 9, again, it's going from a low state to a higher state. And so when it goes from a low state to a higher state, it needs to absorb energy, which is usually in the form of a photon.